Let us now have a concrete example of an eigenvector and eigenvalue. We will explore the matrix A, which is a 2 by 2 matrix, and we want to see whether U or V is an eigenvector of matrix A. Remember that an eigenvector is a vector x such that when A multiplied by x, it will be lambda multiplied by x. The interpretation of lambda multiplied by x basically means that x is scaled by a constant lambda. Now, in the case of a two-dimensional vector, for example, in this case v, this is v here, this is 2, and this is 1. And when we do A multiplied by V, what we are doing, of course, is nothing but putting the matrix A here, multiplying by 2, 1. And you can work it out, and the answer is 4, 2. Now, 4, 2 is nothing but 2 multiplied by the original vector 2, 1, or 2 V. What if you now compare this equation with the definition of eigenvector and eigenvalue, you realize that V is an eigenvector. The corresponding eigenvalue is 2. Visually, it's very interesting. Visually, the vector V is here, and the vector AV lies on the same line as V, and that's the key interpretation. Because V is only scaled, therefore the resultant AV must be on the same line. If it is going on the same direction, then it is a positive constant lambda. If it is a negative, that means it points away from the original V, then the lambda, the scaling eigenvalue, is negative. So that's the geometric interpretation, and here is the algebraic interpretation. All right, let's have a counterexample. The counterexample is, of course, U. Now, if we have U here, which is -1 and 1, and then now we are going to apply A on U. Again, you should write the matrix 3, 1, -2, 0, and multiplying it by -1, 1. And you will get this value here, which is -5, -1. Now, there is no constant AU. There is no constant such that this will happen, and therefore, of course, algebraically, you know that U is not an eigenvector. What about geometrically? Geometrically, you look at this figure. U, which is pointing in this direction, has now changed its direction. Let me clean this up. So this was the original direction of U, and this is the new direction of A times U. Since A times U is different direction to U, therefore, again, we know that U is not an eigenvector of matrix A.